So the first two ways of collecting weather data that we've looked at have been on the ground. We now move on to those that are up in the air, very high up in the air, satellites. These are small spacecraft that carry weather instruments and they orbit the Earth. Now there are two main types. Geostationary. Geo is the prefix to do with land. Stationary means staying put. So geostationary ones are positioned over one location on the Earth. And this is the orbit here of a geostationary satellite. Basically they'll be at a particular latitude and they will rotate around here at the same rate that the Earth rotates. The advantage of this is that it stays fixed over one location and you can see how the weather changes there. So if we take a look, this is the geostationary satellite that's above the British Isles pulling in the weather, or the satellite image, just as I'm recording this video. And you can see this moving and changing in real time here, giving us an idea of where this weather is sitting and where the cloud is sitting. Now I can link that through to the pressure chart, just give you a wee bit of advanced head up in this one. Anytime you see a line of cloud, like you can see here, there's your line of cloud. That's probably related to a front, and there is a cold front that's sitting over us, showing that line of cloud, that front that's bringing that cloud over the top of the British Isles. So that is your geostationary. The second type is known as a polar satellite. Now these satellites orbit, as the name suggests, around the poles. They make about 14 orbits in a day, and basically their orbit takes them that way. The Earth spins underneath them, so rather than staying fixed over one location, they just spin around and round and round, and the Earth moves underneath them. That gives them pretty much of a global coverage here. Now I'm just going to play this little video, and you can see that operating. There it is, circling around the poles with the Earth rotating underneath. And each time the Earth rotates underneath it, the satellite covers a slightly different part of the Earth, and eventually over time you get that build-up of all of the areas being covered. And it does that about 14 times a day, so you get this a gradual build-up of what the satellite images for the entire planet look like. This is, just let that finish because that's very satisfying to watch. It would very much annoy you if I left before it finished, wouldn't it? Come on, you can do it. Come on, come on, come on, come on. Nearly there. How many more orbits? Boom, 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 and we're done. So here is an example of today's geostationary satellite going around the planet. As you can see here, it hasn't yet completed a full set, so we don't have a complete set here over North America. As I record this, North America, it's still night time there, so the satellite is going over the parts of the world that are lit first of all, and as daytime comes to North and South America, it'll go over there. But I can go back a day or two, and there you go. There's the almost complete coverage of the geostationary satellites. Now one of the things that's very useful about this is it gives us coverage of the weather over the oceans. We don't have any land-based stations over the oceans, obviously, but here, for example, at the British Isles, our weather approaches here from the west. There is that line of cloud, there's that front that I was telling you about, that we saw on the other one, but we can now, instead of just zoomed in here and watch it pass over, we can zoom in here, and we can take a wee journey out here and see what's to come. What's the weather looking like over the next few days? Pretty cloudy by the looks of things. So, these satellite images, the two types, are geostationary or polar satellites. They take the images of the Earth. The ones I've shown you there are visible visible satellite images, but they can also take them in infrared, which measures the heat, which allows you to see cloud images at night. And as I've mentioned, they also cover the oceans, which gives you a more complete forecast.